Hi, hello, welcome to i-TUTOR NCERT series. Today, we are going to discuss Class 11 Geography NCERT, Fundamentals of Physical Geography, Chapter 12 Water, Oceans. So, water is an essential component of all life forms that exist over the surface of Earth. The creatures on the Earth are likely that it is a water planet, otherwise, we all would have no existence. Water is a rare commodity in our solar system. There is no water on the sun or any other else in the solar system. The Earth fortunately has an abundant supply of water on its surface. Hence, our planet is called blue planet. Now, what is hydrological cycle? Water is a cyclic resource. It can be used and reused. Okay, so water can be used and it can be reused. Water also undergoes a cycle from the ocean to land and land to ocean. Okay, so it undergoes a cyclic from ocean to land and land to ocean. The hydrological cycle describes the movement of water on, in and above the earth. The water cycle has been working for billions of years and all the lives on the earth depends on it. Next to air, water is the most important element required for the existence of life on earth. The distribution of water on earth is quite uneven. Many locations have plenty of waters while others have very limited quantity. The hydrological cycle is the circulation of water within the Earth's hydrosphere in different forms. Okay, so it is the circle of water within the Earth's hydrosphere and it's in different forms, that is liquid, solid and the gaseous phases. It also refers to the continuous exchange of water between the oceans, atmosphere, land surface and subsurface and organism. Now, about 71% of the planetary water is found in the oceans. Okay, so the 71% of water that is found in oceans. The remaining is held as fresh water in glaciers and ice caps, groundwater sources, lakes, soil moisture, atmosphere, streams and within life. Okay, so the 71% of water is mainly found in oceans and the remaining is held as freshwater in glaciers and ice caps, then groundwater sources, lakes, soil moisture, atmosphere, streams and within life. Now, nearly 59% of the water that falls on the land returns to the atmosphere through evaporation from over the oceans as well as from the places. The remainder runs on the surfaces, infiltrates into the ground or part of it becomes glacier. Now, it is to be noted that the renewable water on the earth is constant while the demand is increasing tremendously. This leads to water crisis in different parts of the world, spatially and temporally. The pollution of river water has further aggravated this crisis. Okay, so we have enough water, but we are also facing some water crisis because of the pollution. Okay, now relief of the ocean floor. The oceans are confined to the great depressions of the Earth's outer layer. In this section, we shall see the nature of the ocean basins of the Earth and their topography. The oceans, unlike continents, merge so naturally into one another that it is hard to demarcate them. The geographers have divided the oceanic part of the Earth into 5 oceans, namely the Pacific, the Atlantic, the Indian Ocean, Southern Ocean and the Arctic Ocean. Okay, so these are the 5 oceans. The various seas, bays, gulfs and other inlets are parts of these 5 large oceans. Okay, now a major portion of the ocean floor is found between 3 to 6 km below the sea level. The land under the water of the oceans, that is the ocean floor, exhibits complex and varied features as those observed over the land. The floors of the oceans are rugged with the world's largest mountain ranges, deepest trenches and the largest plains. Okay, so inside the oceans we can see the largest mountain ranges, deepest trenches and the largest plains. These features are formed, like those of the continents, by the factors of tectonic, volcanic, and depositional process. Now, division of the ocean floors. Ocean floors can be divided into four major divisions. First one, the continental shelf, the continental slope, the deep sea plain, then fourth one, the oceanic deeps. Okay, so these are the four major divisions of the ocean floor. First one, the continental shelf, then continental slope, the deep sea plain, and finally the oceanic deeps. Besides these divisions, there are also major and minor relief features in the ocean floor like ridges, hills, seamounts, goyards, trenches, canyons, etc. Okay, so these are also seen inside the ocean. Okay, so these are some of the minor relief features. Now first one, the continental shelf. What is continental shelf? The continental shelf is the extended margin of each continent occupied by relatively shallow seas and gulfs. It is the shallowest part of the ocean, showing an average gradient of 1 degree or even less. Okay, so continental shelf is the shallowest part of an ocean. The shelf typically ends at a very steep slope called the shelf break. Okay, so the shelf ends at a typically deep slope or a steep slope, and this is known as shelf break. Okay, now the width of the continental shelves vary from one ocean to another. The average width of the continental shelves is about 80 km. Okay, so the average width is 80 km. The shelves are almost absent or very narrow along some of the margins of the coast of Chile, the west coast of Sumatra, etc. Okay, so in this region, the continental shelves are almost absent or they are very narrow. On the contrary, the Siberian shelf in the Arctic Ocean, that is the largest in the world, stretches to 1,500 km in width. The depth of the shelves also varies. It may be as shallow as 30 meters in some areas, while in some areas it is as deep as 600 meters. Okay. Now, the continental shelves are covered with variable thickness of sediments brought down by rivers, glaciers, wind from the land and distributed by waves and currents. Massive sedimentary deposits received over a long time by continental shelves become the source of fossil fuels. Okay, now second one is continental slope. The continental slope connected the continental shelf and the oceanic basins. Okay, so the continental slope connect the continental shelf and the oceanic basins. It begins where the bottom of the continental shelf sharply drops off into a steep slope. The gradient of the slope region varies between 2 to 5 degrees. The depth of the slope region varies between 200 and 3000 meters. The slope boundary indicates the end of the continents. Okay, so the slope boundary that indicates the end of the continents. Canyons and trenches are observed in this region. Okay, so in this region we can see the canyons and trenches. Now third one, deep sea plain. Deep sea plains are gently sloping areas of the ocean basin. Okay, so they are gently sloping areas. These are the flattest and smoothest region of the world. The depth vary between 3000 and 6000 meters. These plains are covered with fine-grained sediments like clay and silt. Okay, so in deep sea plains we can see the fine-grained sediments like clay and silt. Okay, so these are the flattest and smoothest region of the world. Now, oceanic deeps or trenches. These areas are the deepest part of the ocean. The trenches, so which areas is the shallowest part of the oceans? They are continental shelves. Okay, continental shelves are the shallowest part, but the deepest part is oceanic deeps or the trenches. The trenches are relatively steep-sided, narrow basins. They are some 3 to 5 km deeper than the surrounding ocean floor. Okay, so they are some 3 to 5 km deeper than the surrounding ocean floor. They occur at the base of continental slopes and along islands and are associated with active volcanoes and strong earthquakes. Okay, so they are associated with active volcanoes and strong earthquakes. That is why they are very significant in the study of plate movements. Okay, so the oceanic trenches or the oceanic deeps are very significant in the study of plate movements. As many as 57 deeps have been explored so far, of which 32 are in the Pacific Ocean. Okay, so the most of the oceanic deeps, they are found in the Pacific Ocean, that is 32, and 19 in the Atlantic Ocean and 6 in the Indian Ocean. Okay, so as of now we have found 57 deeps and mainly 32 are in Pacific Ocean, 19 in Atlantic Ocean and 6 in Indian Ocean. Now, minor relief features. Apart from the above mentioned major relief features, some minor but significant features predominate in different parts of the ocean. So first one is mid-oceanic ridges or MOR. A mid-oceanic ridges is composed of two chains of mountains separated by a large depression. Okay, so what are MORs or MORs? It's a ridge composed of two chains of mountains and they are separated by a large depression. The mountain ranges can have peaks as high as 2500 meter and some even reach above the ocean surface. Okay, so the mountain ranges can have peaks or the height as 2500 meters and above, and some of them are reached above the ocean surface. Island, a part of the mid-Atlantic ridge, is an example. Okay, so the island, this is a part of the mid-Atlantic ridge. Now, seamount. What is seamount? It is a mountain with pointed summits rising from the seafloor that does not reach the surface of the ocean. Okay, so there are a mountain that pointed summit with rising from the seafloor, but what happened? They does not reach the surface of ocean. Okay, seamounts are volcanic in origin. These can be 3000 to 4500 meter tall. The Emperor Seamount, an extension of the Hawaiian Islands in the Pacific Ocean, is a good example. Okay, so what are seamounts? They are mountains, pointed summits, and they are rising from the seafloor but does not reach the surface of the ocean. Example, the Hawaiian Islands in the Pacific Ocean. Now, submarine canyons. These are deep valleys, some comparable to the Grand Canyon of the Colorado River. They are sometimes found cutting across the continental shelves and slopes, often extending from the mouths of large rivers. The Hudson Canyon is the best known submarine canyon in the world. Okay, so the Hudson Canyon, that is one of the best known submarine canyon in the world. Now, gourds. It is a flat-topped seamount. Okay, so what is gourd? It's a flat-topped seamount. They show evidence of gradual subsidence through stages to become flat-topped submerged mountains. It is estimated that more than 10,000 seamounts and gourds exist in Pacific Ocean alone. Okay, so we can see that more than 10,000 seamounts and gourds they are exist in the Pacific Ocean. Next one is atoll. These are low islands found in the tropical oceans consisting of coral reefs surrounding a central depression. Okay, so what are atolls? They are low islands and they are found in mainly tropical oceans consisting of coral reefs surrounding a central depression. It may be a part of the sea or sometimes from enclosing a body of fresh, brackish or highly saline water. Okay. Now, temperature of ocean waters. This section deals with the spatial and vertical variations of temperature in various oceans. Okay, so in various oceans there are spatial and vertical variations of temperature happens. So, ocean waters get heated up by the solar energy just as the land. The process of heating and cooling of the ocean water is slower than the land. Okay, so the heating and cooling of ocean water, that is slower than the land. Now, what are the factors affecting temperature distribution? The factors which affect the distribution of temperature of ocean water are: first one, latitude. That is, the temperature of surface water decreases from the equator towards the poles because the amount of insolation decreases poleward. Okay, so first one is latitude. How latitude affect the temperature distribution? The temperature of surface water decreases from equator towards the poles. Okay, so from equator towards the poles, what happened? The temperature of surface water decreases. Why? Because the amount of in solution decreases towards the poleward. Second one is unequal distribution of land and water. The oceans in the northern hemisphere receive more heat due to their contact with a larger extent of land than the oceans in southern hemisphere. Okay, so in northern hemisphere there is more land area, but in southern hemisphere there is more oceans. So the northern hemisphere receive more heat due to their contact with a larger extent of land. Now, third one, prevailing wind. The winds blowing from the land towards the oceans drive warm surface water away from the coast, resulting in the upwelling of cold water from the below. Okay, so the wind, how wind helps? The wind blowing from the land towards the ocean. It drives the warm surface water away from the coast, and which resulting in the upwelling of cold water from below. And it results into the longitudinal variation in temperature. Contrary to this, the onshore winds pile up the warm water near the coast and this raises the temperature. Okay, so in contrary, what happened? The onshore wind that pile up the warm water near the coast and this raises the temperature. Now fourth one, ocean currents. Warm ocean currents raise the temperature in cold areas while the cold ocean currents decreases the temperature in warm ocean areas. Okay, so the warm ocean currents increase the temperature and the cold ocean currents decrease the temperature. Gulf Stream, that's a warm current. It raises the temperature near the eastern coast of North America and west coast of Europe. Okay, so the Gulf Stream, that's a warm current and it raises the temperature near the eastern coast of North America and the west coast of Europe. While the Labrador current is a cold current. It lowers the temperature near the northeast coast of North America. Okay, so the Gulf Stream increases or rises the temperature near the eastern coast of North America and the west coast of Europe. But at the same time, the Labrador current, that's a cold current and it lowers the temperature near the northeast coast of North America. All these factors influence the temperature of the ocean's currents locally. The enclosed seas in the low latitudes record relatively higher temperature than the open seas. Okay, so the enclosed seas, they have relatively higher temperature than the open seas, whereas the enclosed seas in the high latitudes have a lower temperature than the open seas. Okay, but in higher latitudes, okay, in lower latitudes, the enclosed seas record relatively higher temperature, but in high latitudes, they records low temperature. Okay. Now, horizontal and vertical distribution of temperature. The temperature depth profile for the ocean water shows how the temperature decreases with increasing depth. The profile shows a boundary region between the surface water of the ocean and the deeper layers. The boundary usually begins around 100 to 400 meters below the sea surface and extends several hundreds of meters downward. The boundary region from where there is a rapid decrease of temperature is called thermocline. Okay, so what is called thermocline? It is a boundary region. Thermocline is the boundary region from where there is a rapid decrease of temperature happens. Okay, so in this layer or thermocline layer, what happened? The temperature is rapidly decreasing. About 90% of the total volume of water is found below the thermocline in deep oceans. In this zone, the temperatures approach 0 degrees Celsius. Okay, so in deep ocean ranges, there the thermocline reaches 0 degrees Celsius. Now, the temperature structure of oceans over middle and low latitudes can be described as a 3-layer system from surface to the bottom. The first layer represents the top layer of warm oceanic water, and it is about 500 meters thick with the temperature ranging between 20 degrees Celsius and 25 degrees Celsius. Okay, so the temperature structure of oceans, they are over the middle and low latitudes. They can be described as 3-layer structure or 3-layer system from surface to bottom. So the first layer represents top layer of the warm oceanic water, and it's about 500 meters thick with the temperature ranging between 20 degrees Celsius and 25 degrees Celsius. This layer within the tropical region is present throughout the year, but in mid-latitudes it develops only during summers. Now the second layer, it is called thermocline layer, lies below the first layer and is characterized by a rapid decrease in temperature with increasing depth. Okay, so in this layer what happened? The temperature is rapidly decreasing with increasing depth. The thermocline is 500 to 1000 meter thick. The third layer is very cold and extends up to the deep ocean floor. Okay, so the third layer is very cold and it extends up to a deep ocean floor. In the Arctic and Antarctic circles, the surface water temperatures are close to 0 degrees Celsius, and so the temperature changes with the depth is very slight. Here, only one layer of cold water exists, which extends from surface to deep oceanic floor. Okay, so there is three layers. The first layer is top layer or the warm oceanic water. So in this layer what happened? It's about 500 meter thick with the temperature ranging between 20 degree and 25 degrees Celsius, and this layer within the tropical region is present throughout the year, but in mid latitudes it develops only during summer. Then second layer is called thermocline layer, and that lies below the first layer, and it is characterized by a rapid decrease in temperature with increasing depth, and the thermocline is 500 to 1000 meter thick. Now the final layer or the third layer is very cold and extends up to the deep oceanic floor. Okay. Now the average temperature of surface water of the ocean is about 27 degrees Celsius, and it is gradually decreases from the equator towards the pole. Okay, so the temperature decreases from equator towards the pole. The rate of decreases of temperature with increasing latitudes is generally 0.5 degrees Celsius per latitude. The average temperature is around 22 degrees Celsius at 20 degree latitudes and 40 degrees Celsius at 40 degree latitudes and 0 degrees Celsius near the poles. Okay, so these are the average temperature. That is, in 20 degrees latitudes it's 22 degrees Celsius, and in 40 degree latitudes it's 14 degrees Celsius, and in poles or near the pole area it is 0 degrees Celsius. The oceans in the northern hemisphere records relatively higher temperature than in the southern hemisphere. The highest temperature is not recorded at the equator but slightly towards the north of it. Okay, so the highest temperature is recorded slightly towards the north of equator. Okay, it's not recorded on the equator. The average annual temperature for the northern and the southern hemisphere is around 19 degrees Celsius and 16 degrees Celsius respectively. Okay, so the average annual temperature of northern hemisphere, that is 19 degrees Celsius, and southern hemisphere is 16 degrees Celsius. This variation is due to the unequal distribution of land and water in the northern and the southern hemisphere. Okay, so the variation is due to the unequal distribution of land and water in northern and southern hemisphere. It is a well-known fact that the maximum temperature of the ocean is always at their surface because they directly receive the heat from the sun, and the heat is transmitted to the lower sections of the oceans through the process of convection. Okay, so we know the maximum temperature of the ocean, that is always at the surface of the ocean because they are directly receive the heat from sun, and the heat is transmitted to the lower section by the process of convection. It results into decrease of temperature with increasing depth, but the rate of decrease is not uniform throughout. The temperature falls very rapidly up to the depth of 200 meter, and thereafter the rate of decrease of temperature is slowed down. Now, salinity of ocean water. All water in nature, whether rainwater or ocean water, contains dissolved mineral salt. Salinity is the term used to define the total content of dissolved salts in seawater. Okay, so what is called salinity? It is the term used to define the total content of dissolved salt in seawater. It calculated as the amount of salt in grams dissolved in 1000 grams or 1 kilogram of seawater. It is usually expressed as parts per thousand. Okay, so the amount of salinity that is usually expressed as parts per thousand or ppt. Salinity is an important property of seawater. Salinity of 24.7 parts per parts per thousand has been considered as the upper limit to demarcate brackish water. Okay, so the salinity of brackish water, that is 24.7 parts per thousand. Now, factors affecting ocean salinity. First one, the salinity of water in the surface layer of ocean depends mainly on evaporation and precipitation. Okay, so the first factor is the salinity of water in the surface layer, that depends mainly on evaporation and precipitation. Second one, the surface salinity is greatly influenced in coastal regions by freshwater flow from rivers and in polar regions by the process of freezing and thawing of ice. Third one, wind also influences salinity of an area by transferring water to other areas. Okay, so the wind also influences the salinity. How? It transferring water to other areas. And fourth one, the ocean currents contribute to the salinity variations. Salinity, temperature and density of water are interrelated. Okay. Now, hence any change in the temperature or density, it also influences the salinity of the water in an area. Okay, so the temperature and density are also interrelated with salinity. Now, horizontal distribution of salinity. The salinity for normal open oceans ranges between 33 parts per thousand and 37 parts per thousand. In the land-locked Red Sea, it is high as 41 parts per thousand, while in the estuaries and the Arctic, the salinity fluctuates from 0 to 35 parts per thousand. In hot and dry regions where evaporation is high, the salinity sometimes reaches 70 parts per thousand. Now, the salinity variations in the Pacific Ocean is mainly due to its shape and larger areal extent. Salinity decreases from 35 parts per second to parts per thousand to 31 parts per thousand on the western parts of the northern hemisphere because of the influx of melted water from the Arctic region. Okay, so in the western parts of northern hemisphere, the salinity decreases from 35 parts per thousand to 31 parts per thousand. In the same way, after 15 degree to 20 degrees south, it is decreases to 33 parts per thousand. Now, the average salinity of the Atlantic Ocean is around 36 parts per thousand. The highest salinity is recorded between 15 degree and 20 degree latitudes. Okay, so the highest salinity that is recorded between 15 degree and 20 degree latitudes. Maximum salinity, that is 37 parts per thousand, is observed between 20 degree north and 30 degree north and 20 degree west and 60 degree west. It gradually decreases towards the north. Okay, so the salinity gradually decreases towards the north. The North Sea, in spite of its location in higher latitudes, records higher salinity due to more saline water brought by the North Atlantic Rift. Baltic Sea records low salinity due to influx of river water in large quantity. Okay, so the Baltic Sea, it records low salinity because it is influxed with the river water. The Mediterranean Sea records higher salinity due to high evaporation. Salinity is, however, very low in Black Sea due to the enormous fresh water influx by rivers. Okay, so in Black Sea also the salinity is very low. Okay, in Baltic Sea and Black Sea the salinity is low because of the enormous fresh water or the influx of rivers. Now, the average salinity of Indian Ocean, that is 35 parts per thousand. The low salinity trend is observed in the Bay of Bengal due to influx of river water. On the contrary, the Arabian Sea shows higher salinity due to high evaporation and a low influx of fresh water. Okay, so the Arabian Sea show high salinity. Why? Because they have high evaporation and low influx of fresh water. Now, vertical distribution of salinity. Salinity changes with depth, but the way it changes depends upon the location of the sea. Salinity at the surface increases by the loss of water to ice or evaporation, or decreased by the inputs of fresh water, such as from the rivers. Salinity at depth is very much fixed because there is no way that water is lost or the salt is added. There is a marked difference in the salinity between the surface zones and the deep zones of the oceans. the lower salinity water rests above the higher salinity dense water. Okay, so the higher salinity water is dense and the lower salinity water rests above the higher salinity water. Salinity generally increases with the depth, and there is a distinct zone called halocline where salinity increases sharply. Okay, so normally the salinity increases with the depth and there is a distinct zone. It is called a halocline where the salinity increases sharply. The other factors being constant, increasing salinity of seawater causes its density to increase. Okay, so the increasing salinity also increases the density of seawater. High salinity seawater generally sinks below the lower salinity water, and this leads to stratification by salinity. Okay, so that is the vertical distribution of salinity. So that's about the chapter. If you have any doubts, you can comment below. For more videos, do like, share, subscribe.